Number 9, they give you two functions. First problem is they ask you g of 10. So you need to look at g of x, and instead of x, we're going to replace it with 10. So g of 10 is the square root of 10 minus 1, which is the square root of 9, which is 3. All right, B, you want f of negative x. So that means you need to look at the f of x function, and instead of x, you have to replace x with negative x. So it's 4 times negative x squared minus 3. Negative x squared is just x squared, so it's 4x squared minus 3. C, they want the inverse function of x. So that's a multi-step process. We want the inverse function for f of x. I need to take this function. Okay. To find an inverse, I'm going to replace f of x with y. Then I'm going to switch the x and y. And then I'm going to solve for y. So x plus 3 is 4y squared. So x plus 3 over 4 is y squared. So y is plus or minus the square root of x plus 3 over 4. If I want an inverse function, I need to choose just one side of that. I can't have both options because otherwise it's not a function. So the inverse function of x is not a function because it's plus or minus. Okay? See, f times g of 2 means take f of 2, which is take this function and replace x with 2. So it's 4 times 2 squared minus 3 times g of 2, which is the square root of 2 minus 1. So it's 4 times 4 is 16, minus 3 is 13, times the square root of 2 minus 1 times the square root of 1, which is 1. So f times g of 2 is 13. E, they want the composition, f of g of x. So we first write that as f, open parentheses, g of x. Then I replace the g of x with square root of x minus 1. And now what I do is I replace x in f of x with the square root of x minus 1. So the square root of x minus 1 squared is just plain old x minus 1 minus 3. So I have 4x minus 4 minus 3, which is 4x minus 7. And the last is the domain of g's inverse. So g of x is the square root of x minus 1. The domain is x has to be greater than 1 or equal to 1 because you must have 0 or a positive number or a square root. And the range is y is greater than or equal to 0 because this means the positive square root. So the inverse function will have domain whatever the function's range was. So x has to be greater than or equal to 0. So that's what they wanted for the inverse function's domain. All right, and that's it for that problem.